So in section 1.3, we're going to take a look at all of the number crunching. So we talked about graphing in sections 1.1 and 1.2. Now we're going to talk about, okay, we have this data set. How can we describe it numerically? So we are really going to focus on describing quantitative data because if you have something that's categorical, really you're just going to compare the different groups. You're going to talk about which category has the most or which category has the least or what's close. But if you have something that's quantitative, we're going to be able to be a little bit more robust in our descriptions. So we are going to measure the center of a distribution. We will use both the mean, which is the average, and the median. We are also going to measure variability or spread, and we'll talk about a term called standard deviation, and then also something called the interquartile range. So that will be a little bit more specific than just the range that we had discussed in the previous section. We will actually be able to mathematically check for outliers instead of just saying something doesn't visually fit the data set. And then we'll be able to make one final graph for quantitative data. We're going to take a look at box plots. And then also, as we go through this section, I'll walk you through using the calculator. And then also, if you don't have a graphing calculator yet, I will talk about how you can use some tools on the web to calculate your numerical summaries. So we have here the mean, which is one of our measures of center. And our symbol for the mean is called X bar. And that's this symbol that you're seeing right here, X with the line over top of it. And so basically that's just our average. So we have our mathematical formula here for it, the sum of the observations over n. Or here, you're going to see this a lot in this course, the subscripts here, x1 plus x2. This means the first x value, the second x value, all the way through the nth x value, so the last one, and then n is your sample size. And so we can condense that a little bit using what we call summation notation. So this is the Greek letter sigma here. And so that is just the sum, or above it there in the text it says that means to add them all up. So it's telling us the sum of all of the x values divided by n. And the subscript of an I that's with the x is just for the individual x values. And so this formula is in your formula packet. When you take the AP exam, there is a list of formulas and tables that you're allowed to use. That one's in there. I don't expect you to necessarily need to use that one, but when we start to get to formulas in the formula packet that you probably don't want to memorize, I'll show you where that one's located just so you have it for reference. We can also describe the center with the median. And so the median is just the midpoint. So you're going to put all of your data in order from smallest to largest and then find that middle value. The only thing that we kind of need to think about is that if you have an odd number of measures or an odd number of observations, then the median is just the center observation because you have a true middle number. If you have an even number of observations, then you do not have a true middle number. And so the median is the average of the two center observations. So it is possible that if you have an even number of entries, that your median isn't actually one of the numbers in the data set because it's the average of the middle two. So here's an example, and you'll see what I mean by an even number of observations right here. You have the data set here from 20 randomly selected New Yorkers, and it gives us their commute times to work. So we're going to go ahead and we're going to find the mean. And remember, the symbol for the mean was X bar, and that just means the average. And then we're also going to find the median. We can use a capital M, or sometimes you'll see the median abbreviated as MED, which would be okay as well. So for the average, we're just going to add them all up and divide by 20. If you're going to do this in the calculator, you do want to be careful and put parentheses around that sum or find the sum first and then divide by 20, because if you don't use those parentheses, then it's only going to take the 45 divided by 20. So you're going to get something much larger than the true average. So our average here is 31.25 minutes, and we do want to make sure that we're keeping those decimal values in statistics. We don't really follow significant figures like you might in some of your science classes, but I would say in cases like this, probably at least one, maybe two decimal places cases would be appropriate. If this was a question on a test and you reported it as 31.3 minutes, that would still be acceptable. So just kind of keep that in mind. I'm not super concerned about the rounding, but we just don't want to over round and round all the way to 31 minutes. And then for the median, here you're going to see the data presented in a stem plot. You just need some way of putting those observations in order. And so you could just make an ordered list. I had shown you how to use your calculator to sort data, so you could certainly do that and then just find the middle number. And so here you have 20 entries. So again, 20 is an even number. So our median is the average of those two middle numbers. So it's really the average of 20 and 25. So our median is going to be 22.5. So you can see on the last slide that the mean and median were very different. And so that really kind of depends on what the distribution looks like. If your distribution is roughly symmetric, your mean and median are going to be about the same. But if your distribution is skewed, or if your distribution has outliers, then your mean gets pulled towards the skew, or it gets pulled towards the outlier. So here we just see in a skewed distribution, the mean is usually farther out in the long tail than the median. So really what that looks like for symmetric cases, I'll kind of squeeze in up here. Here's a distribution that's roughly symmetric. Our mean and median are going to be about the same. So we'd have X bar and M in the middle. Whereas if you have something that's skewed to the left, for example, your median is going to be closer to that peak because it's the midpoint. These extreme observations here are going to get balanced out by observations up on this top end, but they're pulling the average in this direction. So your mean would be less than the median in a skewed left case, and then just the opposite if it was skewed to the right. So if you have something that's skewed to the right, your median is still going to be close to that peak, again, because these extremely high observations are just kind of being canceled out by all of these lower observations here. But the mean factors those values in and is going to get pulled towards that skew. Oops, my symbol's backwards there. Let me fix that. Maybe I'm struggling here. There's my eraser. Okay, so my mean would be, oops, bigger than the median. So we also want to talk about the measure of variability, because we might have a measure of center, but maybe the data is very condensed and compact, or maybe it's very spread out. And so if we just have the measure of center, it doesn't tell us anything else about the distribution. So one measure of spread that we have is called the interquartile range, and we abbreviate that as IQR, and that's really common and acceptable abbreviation. So if you're taking a test, you should use IQR and not take the time that it takes to write out interquartile range. So in terms of calculating the interquartile range, we actually have to find the quartiles first, which are just the quarters of the distribution. So you're going to put all of the data in order and find the median. And then your lower quartile, or the first quartile, is just the median of the bottom half of the list. And usually we just use this symbol for Q1. But again, some of you may have heard the term lower quartile before, and that's the same. And then the third quartile, or Q3, is the median of the observations on the top end of the data set, and sometimes this may be called the upper quartile. But again, as I said, they're called quartiles because they are the quarters of the distribution. And we don't report Q2 because that would be the second quarter, which is just the middle or the median. So that one kind of has a special name for itself. So your interquartile range is just the span between those quartiles. So it's just Q3 minus Q1. So here's an example. This is still dealing with our randomly selected New Yorkers that we found the mean and median of earlier. So if all of this data is put into order, like you see in that second row, then we have our median here. We said that that was 20 plus 25 divided by 2, or 22.5. And then when we go to calculate our lower quartile or our first quartile, we're just going to look at this bottom section and we're going to find the median of that bottom half. So you have 10 values here. So the median is going to be right in the middle of those 10 values. And so here you've got 5 below and 5 above. So it's really the average of 15 and 15, which is just 15. And then up here for the upper quartile or Q3, it's the median of these 10 values. So again, you've got 5 above and 5 below. So Q3 this time is the average of these two numbers. So 40 plus 45 divided by 2. So Q3 is going to be 42.5. So that's going to show up here. Again, Q1 being halfway between 15 and 15, which is just 15. And then Q3 being halfway between the 40 and 42.5, or I'm sorry, 45, which is 42.5. So the interquartile range now is the span between Q3 and Q1. So how far apart are these guys? It's going to be Q3 minus Q1. And it's always that order because when we report measures of variability, we're always talking about it in terms of a range or a positive value. So 27.5 minutes for the IQR. And so in statistics, most times you're not just going to spit out a number and call it a day. You're going to be asked for an interpretation. So something in context. Maybe I'll circle that instead of making it look like it's crossed out. So really, your IQR is the middle 50% of values. So we're saying the middle 50% or the middle half of travel times for New Yorkers have a span of 27.5 minutes. We can use the IQR to check for outliers. And so there is a rule for this, and it is called the 1.5 times the IQR rule. And it's because we're going to multiply the IQR by 1.5 in order to check for outliers. So here, our formal definition says that we're going to call something an outlier if it falls more than 1.5 times the IQR above the third quartile or below the first quartile. So essentially what you're going to do is you're going to take 1.5 times the IQR, you're going to add that to Q3 because that's above the third quartile. You're going to subtract it from Q1 because that's below the first quartile. And that gives you a range for kind of what's reasonable. Anything outside of that range is considered an outlier. So here's an example to show you that check. We're dealing with the same data. So we had our Q1 and Q2 here. That IQR was 27.5 minutes. So now that gets multiplied by 1.5, and that's going to be 41.25. This value gets added to Q3 for the above the third quartile piece and subtracted from Q1 for the below the first quartile piece. So Q1 minus 1.5 times the IQR, that's a negative value. There were no negative travel times, so that tells us there's no low outliers. On the top end, Q3 plus 1.5 times the IQR is 83.75. So essentially anything above or longer are outliers. Again, any travel times less than this would be an outlier, but we can't have a negative travel time. So here's that stem plot of the data set. 85 was the maximum value, which exceeds this. So 85 is a potential outlier in that, or not a potential outlier, but it is an outlier in the data set. So you can use your calculator in order to calculate these number summaries. So you can find the mean, you can find the median. You can find the quartiles, but your calculator doesn't do the IQR for you. So there is a menu called One Variable Stats that shows these two screens that you're seeing here. It actually shows them together, and then you just scroll down to see the rest of it. And you're going to press these buttons in order to get to it. So it's under the Stat Calc menu, and then it's the One Variable Stats option. But you do this after you enter the data. So I'm going to go ahead and pause here for a second, and then I'm going to pull up my calculator so that you can see how that looks. Okay, so here you can see my graphing calculator, and I actually already entered the data into here just to save a little bit of time. But if you want to try this on your own, you can type in the travel times data that was in the PowerPoint into your calculator. So in order to do that, I just hit stat and then enter for that stat edit. And then remember, if you have data in this list one, you can clear it out by hitting the cursor arrow up to L1 and then hitting clear followed by enter. And then you would just go down and type in each entry followed by an enter. So like I did 10, enter, 30, enter, and so on. So I have that data in there already. And now if I want to find the mean, the median, and the quartiles, I can hit stat and then scroll over to calc. And then I just hit enter because I want one variable stats. And some of you guys are going to see this menu that looks like this. You just tell the calculator which list your data is in. So I have it in L1. If you had it somewhere else, like in L3, for example, you would just hit second and then the number 3, and that would put an L3 in there. Frequency list, you're going to leave blank, and then you're going to hit calculate. If your screen doesn't look this way, if it just comes up and says one variable stats and your cursor is right after it, all you need to do is type in the L1. So you would just type in second and then the number 1 for L1. So now I can hit enter, and I can see that mean X bar that we calculated. Some of these other values we're going to use in the next few days. So maybe you're thinking this isn't really all that useful. I can find the mean pretty quickly. You are going to want to be able to use this one variable stats option because it finds some other values for us that you're not going to want to calculate by hand. Okay, that being said, N is 20. That means that there were 20 travel times. And then if I use my cursor to scroll down, I have my Q1 and Q3 listed there. And then I also have the median. Again, the calculator won't find the IQR for you. You do need to know that that's Q3 minus Q1. If you don't have a graphing calculator, there are some options on the web that you can use. One of them is Statlet, and you would just type in statlet.com. Statlet's currently taking a long time to load at certain times of the day, or it's not loading at all, I think because the site is overloaded with lots of students working from home. But they are working to upgrade their site's capabilities. So know that in the future, you might choose to use Statlet. And that is linked under our course resources for you. Another option that you have is StatKey. And so the link for StatKey is also under your course resources, but it's just lock5stat.com. And you can just go right there. And then you've got all of these statistical options available. And so we are just looking for descriptive statistics right now. And we have one quantitative variable. So we're going to select that option, and then that's going to pull the screen open for you. So StatKey does have already loaded data sets for you to work with, just if you wanted to kind of change some points and see how it's going to impact the graph and the number summaries. But you can also enter your own data. So if I hit edit data right here, this is all labeled. It has information about the animal and the longevity, but you can clear this out just by deleting it and type your own data in. I didn't catch all of it. There we go. So you can clear that, and you can even identify like the first column being the labels. You can even get rid of the data having the header row. So I'm going to get rid of all that, and then I'm just going to start typing in my data. So I would just type in a 10 and then a 30 and then just keep going. So I've already done that in the second window so that you don't have to go through and watch me do that. But here we have all of those entries. I did not type custom in. That ended up going in there after the fact. So you just literally type in the numbers just like you would in the calculator. And then once you do that, you do get a graph. So you can use this for graphing. But over here, you get the summary statistics. And this does what your calculator does. So we've got that mean here. We have our N, or our sample size. you've got Q1, Q3, and the median. So you can get those values that your calculator finds for you from the web if you don't have a graphing calculator. Just know that when it comes time for the AP exam, or when you come in for PIT tests, if that's going to apply to you, that you're not going to be able to use sites like StatKey and that you're going to have to use the graphing calculator. So it's something that you probably want to get comfortable with if that's what you're going to be doing. Okay, so I'm going to jump back to your PowerPoint. Your homework assignment for tonight is this page 70, 79 to 89. Please work on that and submit that through Schoology. And then again, you have some optional Khan Academy assignments. So if you think you need a little bit of extra practice on the content for today, you can log into Khan Academy. Again, it's in the top corner. You pull that drop-down menu and go to AP Stats. And then these are the topics that are related to what we're talking about now.